how did you get here? You're sort of journeying to technology. And what do you think about these disruption eras? Is it just a new era, or is it this one's unique?
Wow, loaded question. So can I first say that I feel honored to be on your podcast?
Oh, well, thank you very much.
Yeah, I mean, when you have people like, Danny Kahneman, Nobel laureate.
Yeah, he was pretty fascinating.
I know. So that I'm even in that same room, although he's gone, God bless his soul. Although he's gone, the fact that I'm sitting in the same chair, virtual chair, right, that he's in I'm just like, okay, are you sure you have the right guy? Because,
You know what he would say we do, because he loved, what an incredible human being. I got to kudos to my producer, Carter Cromley, who was able to persuade Dr. Kahneman to have a conversation with us.
Yeah.
He was kind of flabbergasted on, why would you want to talk to me? I'm an old guy who did something from a long time ago. And really, so many people that I know that are industry leaders, not just in our industry, but leaders of ethical capitalism, leaders of software development, leaders in human experience, whatever, love that book, Thinking Fast and Slow, love the ideas that he put forward. And he was so gracious. He was just such a, you want to talk about somebody who's transparent. He just leaned back on his couch in his living room and just had a wonderful, authentic conversation. He didn't mail it in. It was really cool. I had no idea really of the magnitude of interviewing him or Avi Loeb, who's head of astronomy at the time at Harvard, or some of these names. But man, we're all just honored.
There you go, name dropping, making me feel once again.
No, you're well. Soon people are gonna be on there. You had John Koster. I did.
Right.
I knew him back when.
Yeah. So I have a story for you.
Okay.
So I graduated from Vocational high school in 1975 at a little school in Westford, Massachusetts. And in 1975, we had an IBM System 1 in the data processing center. And I was an apprentice there, and they one time asked me to go in and do some electrical work on the panel, and I went in and turned the machine off so I could work in the panel being safe, and then I turned it back on, and the next day my teacher said to me, "John, did you turn off the breakers to the computer?" I said, "Well, yeah, I need to be safe." And he goes, "You know that Mr. Rasmussen spent the next week reconstituting all of the databases? You caused him hundreds of hours of work because you flipped the breaker." So there you go. I was responsible for that was my first data center outage, and my career just took off from there.
You just helped generate activity. Did you ever see the movie The Fifth Element?
I did, yeah.
Gary Oldman is arguing with the professor on ethics or whatever, and he's like, "No, I'm for good." And he pushes the glass off of his desk, and it shatters. And look at all this activity I just generated. And they come out and they clean up all the glass. I love that scene. Of course, then he starts choking, and he gets saved by the priest. But it's a great thing. I create chaos so that order can thrive. It's pretty funny. So good job for creating some chaos.
Yeah, Mr. Rasmussen was very gracious. And, it was interesting because that was such a seminal lesson of everything you touches something else. And I think that began my journey of being a systems thinker, system of systems, thinking broadly. How does what we do impact other things? What's that second, third, fourth, fifth effects of what we do? And I think that has honestly been very instructive in my life and has caused me to think very broadly. I think of myself as being a generalist. I have a few areas that I go deep in, but I'm always looking for where the connections are. And if anything, those throughout my life, throughout my career, it's been find all the things that are somehow related, find out the sphere of influence of those things, and try and find out how those things work together. So these days, I'm more of a storyteller. I synthesize complex ideas, and I try to create a coherent narrative so I can sell an idea to the people who have the money to spend it and where we can put it for good use. So but I actually can trace it back to that. So that's kind of the quick view. I was a what did they call them? These at-risk youth, I guess. I was one of those trouble kids who was always getting into trouble. And so I went to vocational high school because there was no way I was going to go to college. My parents were too poor and my grades were too bad. And so I needed to do something besides pump gas or, although those are fine and noble skills too. Anyway, so I turned out as an electrician. In Massachusetts, if you went to trade school, within a year and a half after you graduated, you could qualify to take your journeyman's test. That's what I did. So I was 19 and a half, and I got my journeyman, my master's license, and I found out, I'm pretty good at this. I'm pretty good at the business side, too. I can sell work, I can do work, I can run crews. And I found myself running a small contracting business in California, Northern California. And I learned that I was pretty good at field operations, but I didn't know squat about the economics of it. So you can work really, really hard, but if you don't understand the business side of it, you will fail. So I thought, I need to get a job where I understand the business side. And I, through a long series of events, found myself as an estimator working for a large engineering construction company, electrical engineering company up in Seattle. And at the time, the North Slope in Prudhoe Bay was booming. And so I got a job as an estimator building on paper jobs that I understood the economics of how to build a 25 megawatt substation in Prudhoe Bay, or running submarine cable, or working on a dry dock, or whatever. I had to build these things on paper. And so I learned the economics of it. And this was back in the days when you literally stripped paper drawings with pencil and calculator and slide rules and did all that. Now, one of the things about being an electrician in Massachusetts, you have to memorize the code book. The National Electrical Code is the Bible. It is the book that actually instructs how buildings are designed. I didn't know that. I thought electrical engineers went to school and learned to design buildings, and actually they don't. They don't know anything about buildings. They have to go out and work with people like me to learn how it actually works. So it turns out that when I went to help out, oversee some of the engineering designs, I would correct the engineer's drawings because I actually knew the code. So, well, you can't do that. And then I knew the economics, and I said, why are you doing it that way? That'll be really expensive to do it that way in the field. And I found myself leading P&Ls, building and managing large engineering and construction projects up and down the West Coast and the Pacific Rim. I found myself learning the economics, learning the engineering, and learning how all these systems fit together, telling the stories to customers. So I got to work with Toyota. I got to work with Boeing. I did like paint hangers. I did managed projects, did logistics for Toyota, warehouses, worked on aviation, put in an autoclave, worked in medical, put in operating rooms and linear accelerators. And I would have these large teams, hundreds of people working for me. And sometimes I would pinch myself because I've got all this P&L responsibility and I'm running highly technical projects. But I didn't have an undergraduate degree. And I always felt like an imposter because everybody else did.
Right.
Anyway, one day I was being recruited and interviewed to get a pretty high-level position at Microsoft, leading all of engineering for their global real estate. And I remember when I filled in after they give you the offer and all that, you have to fill in a little paper application, and I didn't have anything on my secondary education. And the HR person said, hey, you didn't fill in your college work. And I said, oh, I have the same credentials as Bill Gates. And
That's funny.
And I think Steve Jobs and probably Harry Truman. I said, I don't know. And she goes, well, you must be very special.
It's I didn't know this about your story, or at least I don't remember. I was not the exact same, but similar. My trade school was United States Army. I couldn't get along. I don't know if I would be as far as troubled youth, but my grades weren't great. They hadn't invented ADD yet. I was constantly in arguments with my parents. Now, by comparison to people I've learned later, there's no comparison. There's no hardcore drugs or alcohol or anything like that. It was just idiocy and arguments and rebellion and whatever. And I guess troubled would be as good as anything, but not enough for jail time, but just disruption, like serious disruption. And I was the oldest of 5 in disharmony. And so I went as a genius and got a GED and joined the United States military in an airborne unit to escape authority. People have heard this story many times before. And then when I got out of the Army, it took me a number of years to sort of find where my aptitude and attitude fit. And when it did, it was like a rocket ship. And I ended up at the University of Texas, among other things. But I was in my 40s before I decided I just don't like that story. And I don't know why I was now in my almost 60s. I don't care, but in my 40s, I just hated whenever I was doing something, I didn't have an answer on that line. And so I went to school and got a business degree at University of North Georgia here, nice state school. But isn't that interesting on how whatever the narrative that was in my brain, I felt to be validated, I needed to have that thing. Now, certainly, if you're the brain surgeon or whatever, please have your education, your formal education. Yeah, but for what we needed to do, my Microsoft certifications in server and technology and Novell certifications were way more important to the industry back then. Your certifications in electricity and moving through all those different tools that you learn how to use. But anyway, I don't know why that triggered that memory, but it did. And now I just laugh and don't even care. I don't even list it. When we go through credentials, when we're on panels, my name's Dave. I'm with a data center company. Let's just keep going.
Yeah. Well, I think there's some reasons for that.
Sure.
One of the things in terms of technology, this sounds so ancient and it feels ancient. My daughter, she's a director for a tech company. She said to me, Dad, I know you had your career before there were computers. What did you do? Like when you went to the office, what did you do?
Yeah.
And I had to think. I thought, well, actually, that's a really great question, because I had a 5-button phone on my desk, and that was it. And I had HP calculator, and everything I did was on paper. It was written by paper on a mechanical pencil, and everything was done with calculators and extension, and spreadsheets were big green tablets that you wrote on. And that seems so ancient, but what's interesting about that is when there's actually some science around it now. When you put your hand to paper and you write things out, it connects to your brain.
Really?
Yeah. And writing embeds things in your brain. So I remember doing a 52-story high-rise building. I had hundreds of pages of detailed estimates with labor and material costs and extended and all these things. And there would be literally, dozens of pages on a 52-story building for an estimate. Think about all the different SKUs that go in there, and everything had to be labored, busway and conduit and wire and light fixtures and all this stuff. And it was all done on paper. I did the VA hospital. I did an estimate here, and I would learn that. When we moved to computerized estimating, that practice, just a few years of practice of doing that with hand on paper with pencils and calculators, I'd have young estimators come to me and show me the thing, and I'd walk through these pages of computer printouts. I'd go, yeah, something's not right here. And they go, what do you mean? And I would find giant errors in the computerized printouts because I had this intuition that had been built up in this, sort of subconscious of the ability to see through things. And they thought I was some kind of savant. I said, no, I just spent way too many hours on a 10 key, And so I think that's you're going to ask some questions later. I think that I learned something about that, that there's that, knowing what you don't know, and then you know what you don't know, then you know what you know, and then you don't know what you know, right? That's that sort of that curve of learning. And I think that I'd spent enough time doing the manual stuff that I didn't know what I knew, and it became very, very intuitive. I could quickly spot. And it wasn't just me. All the old gray hairs, the guys with the slide rules in their pockets, they could do the same thing because they spent the time doing the thing, right? And it was required because we didn't have the tools to help us do it faster. So, but anyway, what happened was one day a woman at the company I was working for as a senior PM for a big company, I was doing I had a P&L and I was running a lot of projects. She put this box on a desk. It was early 1980s. I said, what's that? She goes, it's a PC. I go, what do you do with it? She goes, well, you stick in this thing called MS-DOS, and then you stick in this other disk called Lotus 123, and they got a word processor, a database, and a spreadsheet. I go, what are those? So I took a little class at Lake Washington Voc Tech on first MS-DOS, how to even get it, floppy disk, 5-inch floppies. Right. And I went, this is amazing, because I was doing a lot of unit pricing and I was doing a lot of that sort of thing. I found, oh, this is amazing. Electronic spreadsheet is so cool. So I began to work on the PC and got really good at it. And my productivity went through the roof. And I remember the president of the company would walk by and he'd see me work on the computer. He goes, when are you going to stop playing those video games and get back to work? And the VP said, leave him alone. He's the highest producing VP we got in the company. Right. And the most profitable. Whatever he's doing, he does the best forecasts. He has the most accurate, and it was because I had spreadsheets, and I became like the the golden haired child. And I learned, and so that was kind of my beginning to learn how to leverage the power of technology. And pretty soon I found it easier. Instead of using honest dictaphone, you pick up, you make the call, the typist types it, she gives you hard copies, you mark it up with, I would just write my own correspondence. And they would say, why do you do that? I said, because it's faster.
Right.
Just get it done, right? And back those days, everything was no email. Everything was, letters on paper, on letterhead, mail. But still, my productivity went through the roof. I mean, I was 5 times more profitable than any other P&L owner in the business because I was just using Lotus 1, 2, 3. Funny story, Microsoft was my first big customer. It was before they went public, and I was doing their data center. Actually, it was after they went public. I was doing their data center, and I showed them the spreadsheet. I was doing a presentation, and the guy looks at me and he said, "What program did you use to present that?" I said, "Oh, Lotus 1, 2, 3." He goes, "Why didn't you use Excel?" I said, "What's Excel?" And he almost kicked me out of the room. And I said, "Well, if you give me a free copy, I'll give it a try and let you know what I think." It was pretty funny, but anyway, yeah. So that was kind of my entry into the personal side of technology. What happened was I did get a job at Microsoft, and the data center I designed in 1988, I was there in 1998, had a catastrophic failure. It wasn't a data center when we built it. It was a 20,000 square foot computer room, which was empty, except for some Wang machines, no joke, some faxes, and some PCs on shelves. There were no servers yet. And they had a catastrophic failure. And what we found out is that was everything in the world was home run to that. Microsoft.com, MSNBC, their payroll, their public people, everything was home run. And when it went down, Microsoft went off the map digitally. And I got called in the middle of the night. We turned it back up. And my new job was to make sure it never happened again. And I had no budget, which means I couldn't exceed it. They gave me the Amex card. And so I hired the smartest people I could, and I found where I was able to recruit really good people, poached them from other companies, and they taught me operations. And we found out we had 26 data centers around the world. All had been built individually without any oversight, without any strategy. We had servers everywhere doing all kinds of stuff. And I found myself moving from the real estate group into the IT group, and I reported up to the CIO. And that's where I learned the stack. That's where I learned about the hardware, the software, the networking, all the OSI stack. Because I had to, right? I had to understand how all these systems work together. To go back to my days of systems thinking, I got to think about how all these systems interlink together. And what I found, David, was that everything was so siloed. Like the software guys didn't know what the network guys knew. The network guys didn't know what the hardware guys knew. And they didn't know what the OS guys knew. The exchange guys didn't know. It was like nobody knew. They lived in these silos an inch wide and a mile deep, not using metric, sorry, millimeter wide and a kilometer deep. But they didn't really, except for what the sides touched, they never knew how their stuff was in context with the rest of the systems. So I have seen my career as trying to understand those, trying to piece those together, trying to couple those together. And so I ended up going to Caltech and getting into executive programs where I could help understand how to lead organizations that had to figure that out. So I kind of leapfrogged the undergrad thing and jumped into the executive ed thing. And so I did get some, but it wasn't the typical, as you guys know, probably in the executive programs, you're doing more collaboration with your peers. You're doing more solving problems at a high level. You're not sitting there taking notes and doing the test thing. But that's where I really learned best anyway. But those were really beneficial times. I did that for about 10 years. I hired some statisticians. We learned how to run Monte Carlo simulations on probabilistic risk. The thing about data centers is they fail, but not very often. So to Daniel Kahneman's, the sample rate's too small to make empirical, data-driven decisions. So you have to run statistical models. That's the only way you can do it. So I hired smart people who taught me about statistical models, and so I learned that. So yeah, it's been an interesting journey following the whole data center world. I jumped out of that for a while. I was a green business officer for Skanska, finding new ways to take sustainable things into the traditional pipeline. And anyway, for 7 years now, I'm back here. I'm T-Mobile, back into the tech space, and now I run a team that does. We're building ontologies. We're building ontological models where we're doing what I just talked about, synthesizing complex things. We've got an ontology engine that ingests like 15 different kinds of data sets, and then we use AI to figure out what the relationship is between those. Because we have millions of data points coming in, we can't possibly analyze it ourselves. So we're using AI to discover relationships and create coherence and help us understand the problem space that we're in so we can take action to make things more efficient, which is kind of our goal.
Well, I love that we landed back there. That's a pretty, my hand started to cramp trying to write down all the things. I can't go back to some of them. We're going to do a second podcast another day because there's like 3 areas I would love to go down. But where you just landed is almost where you started, which was the, when you started talking about the connection of physically writing something to your brain and how that, exercise, as we're human beings are, that's built into us to sort of solidify our ability to learn, et cetera. So what's the balance? Because we're just now talking about the synthesization, if I can get my tongue to say that.
Yeah.
The synthesizing of, when you talked about, I leverage these spreadsheets to do these things. Still a form of writing. I'm still applying myself. I can still find errors when I look at big systems and big computer printouts or whatever. But you've got to give the system some amount of authority. What's the balance between the human and the system so that you don't lose skill or it's marginal? You are able to leverage the power of the system. But what's that balance of authority? What's that balance of interaction as you're synthesizing these things? How do you think about that?
Yeah. Can I
Your
step
show.
on this? Yeah. Well,
Wherever
no.
you want to go.
So I want to think philosophically about this for a moment before I get into you actually asked more of a tactical question, and I'd like to just maybe explore with you some thinking I've done on this, and I'm going to step into so back. Oh gosh, can't believe it's 6 years ago. 6 years ago, when I was in my early 60s, I decided to go to grad school, and they let me in. Mm-hmm. That's great when you have
They hadn't been using the internet. They couldn't do a background check on you yet. I'm glad
they let me in anyway. I think because I just wrote
one of those troubled youths made it in. Congratulations.
That's it. It was it's a Master of Arts in Leadership, Theology, and Society. And it was exactly the place that the itch that I needed to be scratched. I really wanted to think about the moral implications of my life in the world of technology and the moral ambiguity around with which we live. And because as a Christian, as a follower of Jesus, and I call myself a Christ follower rather than a Christian because that seems to be full of meaning, But as a Christ follower who's serious about, pursuing my faith, how does my faith and my values tie with an increasingly morally ambiguous society? How do I think about this? And so I went to school to study that. For 2 years, I studied lots of things that if you're interested, I can send you all my papers. But I learned a ton. And I think a lot about the question that you asked. And I would say that in the business sector, the holy grail is efficiency. In fact, everything about AI, if you hear every argument, every business case about technology, it's about efficiency. Everything is about efficiency. There's a professor from Harvard Business School who comes here, and I asked him about his holy grail, and he said he expects to have a brain implant to allow him to be more efficient. So the technology is the how, but it never talks about the why. Okay? Mm-hmm. So when you ask me the question about that sort of the dimensions of human learning interaction, I would say that there are two sides of this. If the goal is efficiency, then we can build systems to be more efficient. Mm-hmm. If our goal is human flourishing, which is one of your other questions that you had written down, then how do we bring meaning to the things that we do? Now, I'm a musician. I play the electric bass. I play other instruments too, but the electric bass is my main gig. And you'd think, how hard is that? It's 4 strings. Well, listen to Victor Wooten or Jaco Pastorius, and or Sheree Reed, and you'll go, yeah, it's pretty cool. Mm-hmm. And even in my age now, I'm constantly learning and refining the thing, but it takes hours of practice. Part of the human experience isn't just efficiency in getting a task done, It's about experiencing life in its fullness in other dimensions. So I would say that if your goal is efficiency, then technology can be used to make you more and more efficient. If you have other goals, other domains of human experience, then technology has its limitations. And that's more of a philosophical stand. And so for me, I tend to think about reading a book or meditation or other kinds of things as not being suitable for technology. And so I try and turn off technology when I'm doing meditative, other kinds of things that I think are more about human flourishing and connection with other people, for example. There can be helpful sometimes, but not. I'm very careful about how I allow technology to invade those other parts of my life.
So how do you apply that balance now in your role today? So as you have a job, you have a personal life. How do you bring the technologist and the philosopher together to be efficient where you need to get technological efficiency, and to disengage because ultimately it's for the best for the human beings? I mean, the reason why we're doing all these technologies is to serve human beings, I hope. And so how do you bring that together in your role now?
Yeah, that's a good question. I think it's a constant tension. And what I have found is that the people I talk with oftentimes don't have the language to ask the kinds of questions that are most meaningful to them. And I have to tell you that before I went to the grad program, that was one of the things that it did. It increased my vocabulary so that I had a language to speak to those inner longings in ways that I just didn't have before. So part of my mission, if you will, in this current stage of my life, kind of the tail end of, no, I should say the tail end, the end of my professional career in the corporate world is how do I invest in helping the people who I mentor and lead and coach to ask the kinds of questions that they otherwise wouldn't ask. And what I find is that just a few questions, I find sometimes people say to me, I've never even thought to ask that. That's thoughtful. And so if I can stimulate some questions, it'll cause people to think about their own sort of autopilot into whatever it is that they've been told they're supposed to do. For example, I had a guy tell me the other day that he had a moral imperative to advance technology because that's what he's told. We need more technology, he said. And I said, why? And he goes, well, and it's like the story that's been told is that more technology is a better thing just by itself. Okay. As though that's the holy grail is more technology. I just asked him, why is that? Like, what is virtuous? What is good about that in and of itself? Is technology a moral imperative, or is it a handy tool that helps us do things that are moral imperatives? And that's a philosophical question. But I find that students from especially the STEM programs who don't study humanities don't even have that as on their radar as a question to ask. And it is like that maturity hasn't developed. So I see my role as sort of helping sort of those discussions,
Does the organization embrace this idea? Do the people that you're working around? Because it's an unusual thing to bring this humanities idea together, whether it's the efficiency is the holy grail or not, to leverage technology, whether it was, for example, go back to your spreadsheet days.
Yeah.
That president, when it finally occurred to him, wait a minute, he's not doing video games. He's not goofing off. And if I can train 25% more of my workforce to do what John's doing, I get 1,000% productivity increase. Why wouldn't they want to pursue that? So how do you have that conversation where people pay attention, they don't dismiss it, and you're able to affect at least some people with thinking through these in a more in an additional, it's not to replace, but in a more philosophical way on how do I leverage these with this human flourishing idea in mind?
That's a great question. I oftentimes wonder the effectiveness of formal programs for that sort of thing. They're not useful. A couple of weeks ago, we had a senior manager above big management thing. We all had to go through emotional intelligence training, which is like the 5th time I've been through that, right? And you can learn about techniques for doing things, but I think that the most effective way to spread or to propagate ideas is through interpersonal relationships. Mm-hmm. That's just my observation over time, that the most influential people in my life were not the programs or the classes or the courses that I took. It was the conversations. It was seeing life lived and modeled. It was being inspired to be curious on my own and seek out those whose characteristics I found to be noble and good and attractive. And so at this stage in my life, I don't have an agenda per se. I just try and live and engage with people in an authentic way that they are my legacy, right? And I am the legacy of other people, generations of people who have imparted that stuff to me. And I think that my particular ethos is to share that with people in a non-pitchy way. I just share, this is what I see, and it goes to the core of my Christian values, David. What was Jesus' command, right? Love God and love your neighbor. Well, everybody around me is my neighbor. And if I can love them authentically, which means I want their well-being to be there, I'm not going to force anything on people, but I invite them into the world that I'm into and say, hey, let's have a conversation and see what are the longings in your heart and what are the things that meet you. And what I find great is when we can find that synthesis between technology and human welfare, human well-being, human flourishing. That's where I try and find, and it's a delicate balance, because sometimes we have unintended consequences of the things that we do, and we have to look back and go, well, that was a bad idea. Or we had no idea that was there,
Right. What, we don't use the breakers to turn off the computer?
Yeah. It's serious. Yeah. So for me, it's I'm just trying to faithfully live out my life authentically, and I'm just always trying to learn and find new ways to connect with people. One of the things I just love, I love working with people who are so much younger than me, because they ask. They're just so curious, and I find myself inspired and learning from them. So, but this idea of how do I balance the seemingly, and I'll be open about this, the seeming destructive, influences of technology, with the goodness that it brings, because it's both. I think technology is sort of morally agnostic. Right? It's neither good nor bad. It's just it's an amplifier and accelerant of our worst and best impulses. Mine included.
Right. I agree. They're amplifiers. They're morally neutral. They're amplifiers. So how do you leverage them? How do you develop them? How do you leverage them for good?
Yeah. Well, I happen to be blessed to be in a place. So let's go back to sustainability for a moment.
Yeah.
So I think anybody who has probably listening to this podcast and is probably in technology and is probably around the whole issue of sustainability is even if you're not a sustainability, I don't know, if that's not your thing, the reality is we all know in the data center world, for example, that energy is now the limiting factor, right? And there's only so much energy that we have that we can harvest, that we can use, whether it's renewables or traditional, and data centers, which of course are driving the big demand. 9% is what EPRI says it's going to be, or maybe it's already there. 9% of the global energy consumption is with data centers now, and so it's a big fit. So I remember back in high school, back during Earth Day, the very first Earth Day. Was, and I had a kind of a liberal left-leaning teacher who said, we really need to take care of our planet. And we're like, yeah, we should do that. So that's been kind of under the radar. We're not taking care of our planet very well, but sustainability is doing some good things. And so I happen to be in a place where I work for a company that in a nutshell makes its money by monetizing wireless spectrum. That's how we make our money. Some people think we're cell phone providers. Some people think we're, different things. But in reality, we have a whole bunch of licenses of spectrum. We have a network that uses that spectrum, and we find ways to monetize it. And it's a good thing. It allows people to connect. It's all kinds of things. But it also has the problem that it uses a lot of resources, a lot of energy, right? And a lot of that energy is increasingly, especially with AI, computational. So while other people use AI for other things, right, I can find AI and I can find my moral centeredness for me personally, that I can use AI to enable us to do the sort of mission of the business using fewer resources, right? Using less water, less energy, less carbon. So that's our holy grail. And we can't make those investments without data. We can, everybody is selling us, oh, you should come in and use this technology or small nuclear reactors or whatever it is that they want to sell, because everybody's pitching something. But because I'm a systems thinker and my team is we're all systems thinkers, and we have this ontological tool, we can run models that say, what is the best and highest yield for the investment? Because remember, we're a profit-making company, and earnings per share, and EBITDA is what drives valuation, and that's what motivates boards to reward executives. And so our job is to make us profitable, which is good. We can make profit and then make investments into the things that actually make us better stewards of the resources we're using to deliver these services. So that's how I circle it in my mind. I can put my head around that and say, here's something that I can get behind that's mission-driven. We can use smart technology to do better things, and that's good for everybody. It's good for the planet. It's good for the people who are exposed to the damages of, whatever it is. And also, because we have these statistical modeling tools, we can even model how we don't have to have more systems to make us more reliable, for example. Redundancy is a big part of, reliability, and we have to have services, 911 services, E911 services, telemedicine. There's all kinds of things we need to be up. And so rather than just keep building more and more stuff to give us, we can scale that down and right size it so we have tools to do that. So that's what excites me, is that, no, we're not curing cancer. No, we're not finding, but we can do morally admirable things with that's the kind of stuff that I can get behind. And I think that for anybody, find the passion, not just for the technology, but find what the technology does that you can get behind morally. And then, man, it's energizing, because now I'm motivated by more than just my bonus or my stock or whatever. I'm motivated by, we're doing good things here and we're learning things that will help other people.
Are there things that are in the T-Mobile world that, or just you see in the world in general, that you're either in or adjacent to, that are programs or initiatives specifically where, look, in our network topology, in our tower deployment, in our utilization of the spectrum, we are finding, whether it's efficiency or some other area where we actually, here's some practical applications where this is working for us. Let me give you one, for example, in the data center world. As we constantly evaluate the workloads that we're serving in the past, probably 20 years, generally speaking, the minimum standard for a data center has been what we call concurrently maintainable, N+1.
Fault tolerant.
Fault tolerant, thank you. And in the beginning of data centers, it was like everything had to be fault tolerant. In other words, if it were a car, it wasn't just you had a spare tire. You had spare almost everything but the engine block and the transmission, almost everything. And even then, if you were going out on safari, you probably had more. You had gas tanks all around the car, like super, super robust. But over time, what we realized, there's just a few soft points in this thing. And so in a data center, as we moved to concurrently maintainable, usually it was electrical distribution. And what we found was the Uptime Institute, I'm not declaring our company because we've not gone through the certification process, but the Uptime Institute declared certain tiers, tier 1, tier 2, tier 3. Tier 4 was probably the highest tier. That means if wherever you needed one, you had two. So if you needed one substation, you had a second substation.
It's usually 2N+1. Yeah.
Yes, 2N or 2N+1. That's exactly right. And so, but over time, enough of these statistics, to your point about there's not enough data of things just failing, so you had to do statistical analysis. And over time, what we realized was, at tier 2, with a little bit of plus one, a little bit of concurrent maintainability or fault tolerance in just a few of the systems, but with a robust predictive maintenance schedule, statistically is equal to or greater than resilient than a tier 3 or even a tier 4 with an average maintenance thing. So they just emphasized the maintenance on this thing. And why that was interesting, John, was because it's a lot less expensive for a tier 2. It's a lot easier to make modifications to a tier 2. I'm not stranding capital if you just imagine how many gallons of diesel fuel or extra generators that never get turned on except for to do load testing, because the consequence of not being available for a 911 system or an operating room is too catastrophic. And so now we're leveraging these tools, a wide variety of tools, that allow us to get more refined, narrow in on these few areas. They might even need to be 2N, but these other broad areas probably don't even need to be +1 because it's such a statistical anomaly. Or you could do a extra, but this extra would serve such a broad range that we would never consider before because our intuition, back to Dr. Kahneman, told us, no, that's bad news. And then lastly, one of the other things we discovered is if John Koster came to us and said, look, I have this environmental need for a data center. This is the space, power, and requirements that I need to deploy. Well, we might have 6 or 8 people come to us with all of their different requirements, and all of them have built in a fudge factor of 10 or 15%. So when I go build those 6 environments, I have built in for every environment boundaries that are much broader than they need to be. So instead of 10 or 15% margin for 6 environments, I got 10 or 15% margin for every environment. And so anyway, we're leveraging these tools to help us to narrow in on not just more efficient, and not just more cost effective and much more environmentally sound, but actually equal to or greater than resiliency, because we just didn't recognize the patterns before. We had to break the way that we thought of things over time. So I know that's I'm wondering, in your world, do these same experiences apply?
Yes. So I agree with everything you said. I joined the Uptime Institute back in 2000.
Oh, okay.
After the data center outage. So I knew Ken Brill. I knew Pitt Turner. I knew all the folks who came up with the tiering systems. And we used to have robust debates about the merits of those numbers.
Sure.
And by the way, those debates have been, you talk to almost anybody, Christian Bellotti or anybody else who's like the veterans of the industry.
Right.
Well, I remember one time I had a talk with Ken Brill in one of the debates, and I said, so help me understand the assertions of your claim of the different tiers of the number of 9s you could achieve. Mm-hmm. Because I don't think we didn't have any good calculations. They were just assertions. And by the way, assertions are good. It's fine. It's just that I want to understand them. I said, according to the membership, 90% of data center outages are caused by human error during intended changes of state. Mm-hmm. That's correct.
That's true.
And they're electrical. That's at the time that was the number.
Right.
They said, now, if I think about this without even doing the calculations in a Monte Carlo, Markov chain, or any other kind of simulation, the more stuff you have, the higher the chance that some of it's going to break. And the more changes of state you have to do in order to maintain them. Doesn't that seem a little bit complicated when you have all of these systems that are all cross-connected that you have to maintain, and that means people doing stuff, and that means higher probability of an error? Or statistically, the more things you have, the probability that one of them will fail is higher. And so then it went back and forth, and so there you go. And so one of the things that we did exactly what you did is we said, well, let's see if we can't. Let's come up with some models and test the models. And that's where we came up and we did the Reliasoft or the different reliability models that said the most important thing for reliability is staffing, training, and procedures that are followed, more than more stuff to put in. So to your point, you are correct. And I would say that back when I took over data centers, you had a server with an application with disk-attached storage, which is a bunch of storage that was attached. It was called DASD, and it was sitting on the server. And then every new application had a new server. So when they went to storage area networks and then VM, all of a sudden you began to see compression. So that was another big, huge, win for sustainability and cost too, for that matter, because now you could run multiple applications on the same machine. It was disaggregated from the storage, and that's a good thing, right? So now we have that. Well, now we have containerized stuff. We have Kubernetes and Magellan and other ways to do containerized compute, all right? And we have CPUs and GPUs. So one of the things we've been doing is going up inside the stack and saying, how efficient is our computational loads, our workloads? How do we know? And do we have way too much equipment spinning? So we did some, back in 2007, maybe 2008, when I was at what was then called Savvis, we threw a thing in a lab and we ran CPUs up to their maximum load and then dropped it down, threw synthetic load on. We watched the power input. And what we found was that the CPUs were inherently inefficient, that we would take and peg a CPU in the total power load, and then we would drop it down to idle. And you know what the power load would drop to? 50% of the max. So doing no work, the thing was still spinning at 50% of what its maximum would be, and the corresponding heat load, and regardless of what your PUE is, they're 100% inefficient. So we have all this energy being used to spin it. So when I came here to T-Mobile, I said, can we take a look at this? And so we did. We put it in the lab. We saw the same thing. And now actually going into some of our servers, we did nothing more than change the BIOS and put Intel Power Management on it, and we dropped it by 60%.
Wow.
Huge. Right. 60%. That's insane.
Yeah.
So now we're working with another company who's doing some really smart things. We're doing workload orchestration about when that token moves from CPU to GPU, they're using AI to optimize that workload. So it only needs to be there when it needs to be there. So even within the Kubernetes environment, we can move the workloads around so that they're only being used the most efficient moment, and that's dropping another, So I think that some of the biggest opportunities right now, especially with the AI workloads coming, is using our computational resources far better up inside the hardware stack. And even the bloated code, they're stripping bloated code and finding there's instructions you don't need, right? And so anyway, one of the questions is, how far do you go up? Well, the good news is these days, using AI, we can give instruction sets to Python to find that stuff and make those changes much more quickly than we've ever been able to do before. But it's a vast field.
Right.
Imagine, I was talking to one of my old colleagues at Microsoft, and he says, our goal is to continue to grow our business, but never having to build another data center. And the only way to do that is to find better ways to use this stuff inside the computational environment. So part of our tool set, that's what we're looking at. We're trying some things out. I think that's where some of the big opportunities are.
This kind of comes back to our balance question. You leverage these tools to help go do that stuff, but then how do you maintain intuition? Or do you just cede it all to the systems to have the intuition? Like, I don't know how you do that. I want the result of the sustainable, efficient excellence, but do we just want the systems to be able to do that? Do we want, where's that balance at? Yeah,
that's a great question. I think that's the tension, and we could spend another whole hour talking about that. What I'm coming to believe is that so AI doesn't know when it's wrong. Right?
That's true. Neither does my 20-year-old, but that's neither here nor there.
No, I'm wrong either. But it doesn't know when it's wrong. And so it always takes domain experts to be able to figure it out. Mm-hmm. But what I was going to say is the thing that I said earlier about the silos in the IT world, it's now magnified even more. All right. The applications architects don't know how the hardware is built. The hardware doesn't. And everybody acts like they know. You can sit down with the big end company with all the AI hardware, and they will talk like they know what they're talking about. But they really don't. They only know their part. And so the business use cases, the networking, the storage, the CPU, the GPU, and what workloads go, they all know about. We all talk about it, but nobody really knows. And so I will tell you that on this little thing that we did in the lab with Dell and with Intel, I would have 18 people on the call. Each one had an expertise, but nobody knew the whole. And our job was to figure out who wasn't in the room that needed to be there. And of the ones who were there, what did they know? and how can they contribute to the whole of what we were trying to do. It's amazing that a simple IPM upgrade and a BIOS upgrade took 18 people to have a say.
Right.
Right? Because you got application, you got latency, you got all kinds of things, application performance, you got database. I mean, there were so many aspects to it. These system of systems are so complex and nobody knows how it all works. They only know their part. Mm-hmm. So I think that part of the holy grail, if you will, and the hope is that building these ontology tools that pull this in together, look for patterns, look for dependencies, look for nodal, parent-child relationships in terms of data architecture. That's the place where you gain all those efficiencies. You can't do it from the intuition. It's too big. The little world that I was in was electrical systems on industrial and commercial buildings, right? This is exponentially more than that. I don't think we could rely on that. Instead, what we'd have to do is say, when we run these AI things, how do we know? And one of the things that we did is we don't know when it's wrong. So we built the data hygiene tool, and then we said, if this is right and this is right and this is right, then it's right. Mm-hmm. But we didn't know how to actually analyze it. We had to do that. So one of the things that happened is we had a data hygiene tool that we have at least now 50, 60,000 sensors out there that are giving us millions of points of data. What we didn't know is if a sensor was wrong. We didn't know if it wasn't right. And our data hygiene tool found there was one that wasn't reporting. And in fact, one of the meters that hadn't been reporting for 2 years, but we didn't know it wasn't reporting because we didn't see it. Mm-hmm. But the data hygiene tool said, we should see this and we don't. Go find it. So we found it. And because of that, it made one PU calculation that resulted in $11 million of capital, stranded capital we didn't know we had. So those are the kinds of things that I think that AI can do for us. We just have to have the imagination and creativity to say, how can we know that what this is right? How can we validate that this is true so that we can trust it to make, for us, multi-billion-dollar business decisions, right? Yeah. And so that's what we're working on right now, actually.
That seems. I just had an opportunity. I think we released the podcast this week to interview Craig Pennington, who is one of the head of data center engineering at Oracle. Mm-hmm. And I'll bet you a third to half of the conversation was about collaboration. It wasn't even about technology. It was this skill of collaborating and having a mindset of in the middle of this asymmetric curve, these changes, this acceleration of speed and scale, whatever the application, there's so many things that they're going to be deploying in 18 to 24 months. That they've already bought the gear, the GPUs, the whatever, but their modeling's just been digital twins or because the infrastructure doesn't exist. And so they're making assumptions. And it's not that everybody. This is normal for this, all the big hyperscale providers working in this space. So I guess my question is, in the middle of that, how do you get a culture of either to maintain or to develop this collaboration? I mean, how do leaders in organizations work together to collaborate in increasing complexity or systems in the middle of uncertainty? Because that seems to be one of the most important skills we can develop. Those that don't do well aren't going to survive.
Yeah, I don't know if I have an answer, but I think it's a bite at a time. Okay. The epiphany that we had was when we first gathered these unwilling but forced 18 people into the room, into our Zoom calls, to try and unpack this. It was a lot of unpacking. And you could tell that people were like, I don't know why I'm here. You can tell they're really disinterested. Right. But I had managed, because we have a pretty small ecosystem here and I'm pretty high in the organization, I was able to say, no, you will show up. And the VPs all said, no, you will show up. This is an important thing. They didn't care because they live in another world with their own little things. And when we came up with the results of the savings, it was like a religious conversion for everybody there.
I bet.
It was like, wow. I told them, working on the hardware part of it so long, I said, look, everyone here can now take their A+ test, And it's like, and they go, what's that? And I had to tell them. Anyway.
Yeah. It's so, I'm sorry to interrupt, but it's so bizarre because my daughter, my middle daughter, went and got her digital art and Korean degree. She's fluent in Korean. She had this whole mission and purpose. So she's graduated from school debt-free. Just last night, she's telling me where she is on her cybersecurity certification. No. And when she's done, she's doing her CompTIA A+ and her Sec Plus. And I was like flashing back to 1995 or whatever it was when I was at the university doing my Novell 312 certs and my A+ and my CompTIA, and I was like, oh my goodness gracious. So that you busted that out now, isn't that funny how these threads, for all of our talk about AI and all these other things, back to critical thinking, systems of systems or whatever, these foundational layers. Anyway, I'm sorry, but I just thought that's cool.
What's so fun is that in the world that we live in, the one thing that I feel very blessed is that, and you and I both, is that we've had one world in the one foot in the digital and one foot in the physical.
Yeah.
And the thing about technology is hardly anybody I work with actually thinks about the physical. In fact, it's just an abstract to them. It's just an abstraction. It's like, oh, the physical. And when we're sitting in the world actually figuring out the actual BIOS, which is software, but it's sitting on physical. It's like it's part of the system, right? It's like, oh, and when they saw what the savings opportunity was, everyone got so excited that it was almost like being in a lab in school where you saw like some transformation happen. They all just went, this is cool.
Right.
All right. Now I feel like I don't need to sell this anymore. And they're all, now we want to figure out, well, how do we scale this? How do we do this? And I've got like now a core team of people who are believers. And I think that becomes infectious. I think when it's top down, you will do this thing, check this box, take this video training, you will collaborate because collaboration is a good thing, versus you experience it in a group where together you saw the synergy, and then people go, what other problems can we solve together? It's like people get it because they experienced it. It wasn't because they were taught it in a classroom or modeled on some video. It's just, and that's what I think the human experience is about, right?
For sure.
It's about that doing it in relationship to others. In collaboration. It isn't because it's forced on you, it's because you see it, and then there's something inside of you that just goes, it's like being in a band and you're all kicking on the groove, right? Like I do, When you're out of groove, it's not good. Playing my bass guitar by myself is not any fun. Being in the band and cranking out something that's beautiful that we all do together, you just want to keep doing it. And so I think that's kind of how it is with teams and teamwork. Sports is another metaphor, right? You can use whatever you want, but it's the doing it together that creates that cohesion, I think.
It's when people get converted to an idea you were talking about before, to being followers. In other words, an idea is introduced. They're not sure what they think about it. They have an experience with it that maybe not for everybody, but for some group of people, they're like, wow, that's the truth. I can resonate with that.
Yep.
Or at least what piece of it I can understand, whether that's your personal faith, your technological implementation, your relational things with other people, but I'm connected to this. I may not have all the answers on the periphery, but I'm connected. And now you're that leader, that big idea, whatever it is, I'm a follower of that. I'm not just a believer of that. I'm a follower of that, and I'm going to pursue that. And when that happens for humans and we're able to align on that, that's when the biggest changes and the biggest innovations, I think, happen. And personal satisfaction. When I'm aligned to mission and purpose beyond myself, in my job, in my, whatever that is, my family, my place of worship, or the things, whatever the things are, it transcends. And I know we're over, but let me ask you this before we wrap up, if you don't mind.
Yeah. Sure.
The easiest question for this whole hour and some odd minute conversation: what's the next big disruption? Is it just more of the big disruption we're in? Or do you think that there is there a horizon thing? I don't know. It's for me, sometimes when I get asked that, John, other days I feel very strong about a particular thing. And other days I'm like, when you're in the middle of, light and noise and motion going on around you, and they say, hey, what's the next big light, noise, motion thing? I don't know. I'm inundated right now. But if you think about what that next emerging trend, future trend, or whatever might be, what do you imagine, or what do you think your team needs to be prepared for?
I think we're in a Gutenberg printing press moment right now.
Okay.
All right. I think that literacy is right behind. that transformed civilization, right? Before that, people were illiterate. There was no written. There was very few people who actually could read and write, and there were very few documents they could read and write. And so there was a very small group of people. And so ideas were proliferated through the printing press and then on through the internet. I think this is even bigger than the internet. I think AI and large language models, I think the very question of what does it mean to be human? What is a well-lived life? Who are we? Where are we? Why are we? That is the big challenge in the midst of the proliferation of data. And the titans, whose mission it seems to be, is to own the mind space of people. I think that's a philosophical question. That's a theological question. I think we're in the middle of it. I think we're in the middle. It's not the next big thing. I don't think the next big, I think we're in the next big thing, and we haven't seen what the implications are for humanity. There's a guy named Wendell Berry. He's a really cool author. He's written a bunch of books. One of them is What Are People For? It's a great book. And the question that I ask people is, what is the well-lived life? And how does technology promote that, or how does it harm it? And we all have ideas about what that looks like. You talk to a million people, they have all different ideas. But I will leave you with this, though. At the end of the day, what is the end game? We're all finite. We don't get to choose whether our life ends in death. Not yet. Everybody who tries to cheat it, nobody has cheated it yet, except one person. And so the question is, I was talking to my 97-year-old dad on his deathbed, and he was coherent right to that. In fact, he was cracking jokes just, minutes before he died, because he was just funny. He was a funny guy. But I asked him, I said, Dad, you've been through the World War, you've been through depression, you've been through, blah, 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 blah. I said, at the end of the day, I always want to know, what is a well-lived life? What's the most important thing? Of all the things you've learned in your 97 years? He said, oh, Johnny, that's an easy one. This is like 2 hours before he expires.
Right.
Oh, Johnny, that's an easy one. He said, there's only two things. The capacity to give and receive love. And I think that is the heart and soul of the gospel. It's the heart and soul of human need. We want to love and be loved. And so when we think about the world in which we live in, one of the rubrics, one of the things I look through is, how is this the most loving thing that I can do? Or how can I learn to love better in the midst of all this? And that's like a really big, crazy, highfalutin thing, that existential. But no, that's every person's need. We all want to love, and we all want to be loved. That's our long. And we take, philosophically and theologically, we take imposters to fill that hole in our lives. And my goal right now is, with technology, with all the stuff that's just being forced upon us at a rapid pace, how do I maintain my centeredness in a love-centered life in the world that's kind of spinning around me, trying to suck me into its tentacles? I'm in the space, right? Obviously, I'm here and I'm participating in all of this. And yet at the same time, I have that balance of, how do I live a centered, love-centered life in the midst of it all?
Right.
That's my struggle and my challenge. It's worth living, though.
I agree. I think, obviously, thank you for sharing that. I resonate with all of that. I also think that sometimes when I have a similar philosophical conversation with folks, or it ends up in the philosophical, and they're kind of surprised because it started off in the technical, perhaps. Right. And I don't mean to be heavy-handed in this conversation or any of those conversations. I just want them to think about, look, I want to be part of this world because I want to affect technology, its deployment, its development, to lead towards that well-lived life. Like I have no aversion. It's just a matter of, what's the application? Am I using this thing to pretend to give me love or to love it? Well, that's going to lead to not great outcomes. I have kids that are of a certain age that somehow we got caught up in this. I love these technologies. I love these tools. I use them. I leverage them all the time for human flourishing, for my own healthcare, for so many amazing things that I don't even want to have to do. But if they start standing in the gap to fill a human need that only humans can fill, that's when I think we start getting. And so I want to be involved, not just to develop, because I'm a technologist and I love to be part of it. My curiosity is how I'm built and wired. But I also want to bring that philosophical element that says, So what's the unintended consequence? We're not anti-computer or whatever, but maybe we just don't pop off the breakers. We're not anti these other things. By the way, shout out to Wang computers from back in the day. I remember back in the day when a Wang computer was a big deal. Like it's, all these things on the evolution of, to containers today, to Kubernetes or whatever. But
I worked for Dr. Wang.
Did you really?
I was an electrician at Wang Laboratories in Lowell, Massachusetts. Yeah, I wired his computer in his office. And
man, I give so much. I used to run my mouth about so many things, and now I just give homage in a time and place, whether it was TI or Perot Systems or Dr. Wang or all of these things that have come along over the era, these big thinkers and whatever. But I just think that part of, at least what drives me, and I suspect drives you, as long as I can be gainfully employed and I can affect the human beings around me as we develop and apply technology, let's do it in a way that is ethical, that accomplishes the mission and purpose, I hope, that leads to human flourishing, and not be afraid of it, but just make sure we're applying it correctly. I don't want to be afraid of the hammer. I just want to use the hammer correctly.
Right. Understanding, too, that capitalism and technology, these are all just tools, right?
That's
they're just and they're a reality we live in, and how do we harness them for good? And
John, thanks for coming on the show. I can't wait till
I'm kind of disappointed. I thought you were going to ask me what my family would think I was thrown in jail for. I had a great answer for you, but I'll have to wait for the next.
Whoa! It's my podcast. Thank you, sir. So to set this up, tell the audience why you threw that out there.
So here we were in a very serious panel.
Yeah.
In front of a large audience.
You and I.
Yes, and David was the man at the podium, and the panel were sitting on chairs, and we're having a very serious discussion. And with a very serious, business-like voice, he says, "Okay, I have this final question for you. If your family knew that you'd been arrested, what would they automatically assume you'd been arrested for?" And he caught me flat-footed. Nobody ever does that. That is the first time I've ever been caught with a. Oh my gosh.
You're innocent. But now that you've had time to reflect upon it, what would it be?
Oh, it's kind of lame. No, I was thinking about that. I thought, when I was young, it would have been reckless driving on my motorcycle. Okay. But now it would probably be doing some sort of perjuring myself to protect an innocent person, or some civil disobedience to protect the marginalized. I would like to think they would say that. I'm not saying they would.
Right.
I would like to think that I was doing something noble, smuggling Bibles into a forbidden country, or something, that it would be doing something good, not something bad. But anyway.
John, thanks for coming on the show today. I really appreciate it.
Enjoyed it very much. Thanks for the invitation.
Yep,
we'll see you soon.
I look forward to the next one. Hey, if you guys liked it, click the like button. And if you loved it, subscribe. We'll see you next time, everybody. Have a good one.